Then we have the next talk, and I welcome Ara. And
hello.
Yes, are we getting connection? Hi, Ara. Are you joining us from Spain now, or?
Yes, I'm in Spain. Yes, correct.
Okay, so slightly in a warmer place than what you see behind me in the picture.
Probably.
Okay. Yeah. So, hey, you are ready to go, and you have a service mesh topic, yet another way of doing APIs and dealing with APIs. Go ahead.
Thank you. So yes, welcome to this talk about progressive delivery in Kubernetes without actually using a service mesh. My name is Ara Pulido, and that's my Twitter handler. So if you have any questions after the Q&A that you want to cover, please reach out. Progressive delivery is a topic that is very important for API-driven architectures. My employee, Datadog, is a monitoring and analytics platform that helps companies improve observability of their infra and applications, including, of course, Kubernetes as a platform, but also the workloads that you're going to run on top of it. And what is Kubernetes? Kubernetes, many of you probably already know, but it's a container orchestration platform that helps you run containerized applications in production. It's completely open source, part of the CNCF Foundation, super popular open source project. But today we are going to be talking about progressive delivery, something that it's becoming more and more popular. This term in particular was coined in 2018 by Brett Monk and Lodge Dargley when they were trying to find a term to put together all those deployment techniques that were appearing. And those deployment techniques are different. There are many ways, but there are things like canary deployments in which you have a new version of your service or your API, and you want to deploy to production, but you don't want it to deploy to all your users. You want to only deploy to some of them, gather data back, gather telemetry data, and make some decisions. Should I continue moving forward to more and more users, or should I roll back? But it can also include things like another type of shift in traffic, like things like A/B testing. You have two different versions of your service in production, and you have an hypothesis and you want to make this experiment. Like, for example, which of the two services is going to drive more sales, or things like that. And also includes things, other things like green, blue deployments, etc. So basically, it's having code in production that not every user is going to see. And by see, I mean experience. Like, not every user is going to experience that code in production. In order to be able to implement progressive delivery, something that is super key is having a good observability strategy. You need to have a clear way to gather that telemetry data back, and also to have a strategy on what metrics are you going to look at. How are you going to decide whether to move forward or roll back? Or in the case of A/B testing, how do you decide which one you're going to take? So having an observability strategy is super key to implement progressive delivery. So progressive delivery and service meshes, why these two terms are so connected together? If you try to Google, for example, how to do canary deployments in Kubernetes, it's probably you're going to get a lot of responses talking about using a service mesh one way or another. Why is that? So let's recall quickly what is a service mesh. Particularly in Kubernetes, you have the data plane. The data plane means that every single container, every single part of your cluster, the networking communication, instead of happening from your container application to container application, is going to go through a proxy, a networking proxy, which in many cases is going to be Envoy. Another CNCF project is very popular. So all that communication never happens from the actual application code to application code. It goes through the proxy through localhost, and then the proxy decides where to send that traffic. Then we have the control plane, and the control plane are projects like Istio and Linkerd and Kuma and others. And control plane, what they offer is a rich language, usually in Kubernetes, they usually means new Kubernetes objects, custom resource definitions that allow you to define what do you want to happen in a very high level, rich language. What do you want to happen to your traffic? And the control plane is going based on that definition. It's going to configure those networking proxies for you. So, and because you have this language to very high level, very easy to use on how you want to move your traffic around, this is exactly what we need for progressive delivery, like shifting traffic, splitting traffic, duplicating traffic if needed, etc. So if service meshes are that well suited for progressive delivery, why I'm creating a talk about not using them. And by all means, I think service meshes are great. If you need to use them, use them. They're great also for progressive delivery, but the problem with them is that they tend to add complexity to your cluster. Basically, suddenly you have all these networking proxies that you need to understand what's happening. You have this abstraction layer added by the control plane, new objects, new services, etc. So if you don't need a service mesh because you don't have that many services and you only want to start doing some progressive delivery and you're not ready yet to add a service mesh, as I said, there are alternatives. So I'm going to be talking about 3 ways in which you can, well, actually 2 ways in which you can today and 1 in which you will be able to very soon. So the first one is service networking, and this is just normal service networking in Kubernetes, which is service networking in Kubernetes, just in case. So when you have a deployment in Kubernetes, you can have several replicas of your same workload. And the reasons why you want to do that is things like HA or scaling your application, etc. So when you have a client pod that wants to talk to your workload, to your service, how do they pick? How do they pick between the many replicas that you may have? So this is done through a Kubernetes object called a service. And services are very overloaded word, but basically here what I mean is a Kubernetes service. And basically what it does is in Kubernetes, every node has a component called kubeproxy, and kubeproxy has several implementations, but basically what it does is to load balance the traffic between the pods. And in its most basic implementation, all the pods part of a service will have the same weight. Basically, it will choose one. It doesn't matter which one. So how does a service know that which pods are part of it? What are the endpoints of that service? And the way Kubernetes does this is very simple. It does this through labels. So when you create an object in Kubernetes, you can pick some labels. It's just metadata. So let's imagine that we have a service that offers discounts in our application, and we assigned these 2 labels, app website, service discounts, to this particular service. So when we create the Kubernetes service object, we create it with a selector, which is basically the counterpart of those labels. And basically we tell the service, any pod that has app website and service discounts is a potential endpoint for this particular service. It doesn't know anything about the code that is running. It's just metadata and selectors. That's the only thing that it does. So let's imagine that now we have a second version of a service and we want to deploy to production, but we don't want to completely remove version 1 just in case, and we want just some users to experience this new version. So one of the ways that we can do that very easily is creating a second deployment. We create new code of our service, we build our Docker image, we push it to a registry, and but we add the same labels. Again, labels is just metadata. It doesn't know anything about the code that is running. We add the same labels that before. So at that point, our service says, okay, I have a new potential pod, a potential endpoint for my service because it has the same labels, although it's running a different piece of code. At that point, you're already doing some progressive delivery because 20% of the traffic is already going to the version 2 and only 25%. And at that point, you can gather data, and gather metrics, make decisions. So this is really a very, very simple way to start doing canary deployments. Obviously, the downside is that this is basically more or less what you can do. The only thing that you can do is to randomly shift traffic to a new version. And granularity is not great. In this case, 25% of the traffic is going to the pod running version 2 because they all have the same weight. So if you want to reduce that percentage, you would need to increase the number of replicas of version 1. So for example, if you have 9 replicas of version 1 and only 1 of version 2, 10% of the traffic will go to version 2. So this is the first way. The second way is Ingress. So what is the Ingress object in Kubernetes? So when you have traffic coming into your cluster, external traffic, you do that usually through a load balancer. But once you have traffic in, you may have several services that receive external traffic. So for example, if you have a corporate website with your careers page and your founders bios, etc., but that requires external traffic, but you may also have like an e-commerce shop, for example. So how do I'm able to, with just one load balancer, to shift the traffic around? And the way you do that in Kubernetes usually is with the Ingress object. And the Ingress object allows you to create rules with the URLs and the paths. So in this case, to put this as an example, we are doing an Ingress object that says any traffic that goes to foo.bar.com, if it goes to /foo, go to service 1. But if the path is /bar, go to service 2. And you can create rules to move to different ports, etc., etc. So very, very simple object, but very useful in Kubernetes. One of the things that happens with the Ingress object is that the Kubernetes controller that is deployed on every Kubernetes cluster, the Kubernetes controller doesn't include an Ingress controller. It includes things like a replica set controller, deployment controller, but not an Ingress one. And why? Because Kubernetes is relying on third-party implementations of that controller. And there are many open source projects and companies doing these things, usually on the gateway area of things like Nginx and Kern and Ambassador and Contour. All these open source projects and companies are doing Ingress controller. So these people started thinking, okay, because we are shifting traffic thanks to the Ingress object, this could be a good place to implement canary. But the Ingress object doesn't have a way to implement canary. So what happened in the end is that every single one of these implementations will have its own way to do canary. So let's see an example of how Nginx does it. And the reason why I'm selecting Nginx is because it's very simple, it's very popular, but any other will have another implementation. So let's imagine that we have this application where it has a service front end that receives external traffic and then talks to a couple other services. And I can create an Ingress object that basically says, okay, anything that goes to shopcorporate.com, move it to that service. But let's imagine that now I have a second version of the front end. And that second version of the front end, I want to deploy as a canary. So Nginx allows me to add this couple of annotations to my Ingress object in which I say, okay, actually this is a canary and I only want 10% of the traffic to go to this second version. But annotations are just metadata. They are not part of the object aspect. So the Ingress object doesn't have the capacity to add canaries, but because it's a place where we shift traffic very early into our cluster, those implementations are starting adding different ways of adding that. So they include things like either annotations they started kind of hacking the object, adding annotations or adding intermediate objects. But basically, if you're not using Nginx, if you're using something else, go check out the documentation of your Ingress controller, because probably they have a way of doing these sort of things. But again, it would be different depending on the controller, because the Ingress object doesn't have that. Which brings us to something that tries to solve this, which is the Gateway API. And this is alpha, that's why I said that something that you will be able to use in the future. This is a new API in Kubernetes that aims to be a set of APIs to deploy L4 and L7 routing. And this is one of the first differences between Gateway API and Ingress. Ingress is just L7. The Gateway API is a richer API that also does L4. And the Gateway API, and this comes from their website, is designed to be generic, expressive, extensible, and role-oriented. And I highlight generic because that's the main goal. That was one of the goals when they started working on this project. So the same people, a lot of the same people who were doing those different implementations got together and said, okay, we are all hacking this Ingress object in different ways. Why we not create a working group and we start creating a richer API, because it's clear that we need one, so that we all follow the same API. We don't start making things different depending on the implementation. So this is how it's going to look like. And the Gateway API, again, is super rich. It's not like the Ingress object that is only one. It has several objects, Gateway class, Gateway, etc. But I want to mention this one because it's going to be the one that it's very, very similar to the Ingress object, which is HTTP route. It's basically L7. And as you can see on the spec, you're able to create a canary and say 90% of the traffic goes to service front end and the other to service front end too. And this is not an annotation. This is not part of a hack that we do on the object. This is part of the spec. So all the implementations that want to implement this API will need to be able to do these things following that API. And again, same people, here is an example of an issue in the Conn repository where they're implementing the Gateway API. So the same people who have Ingress controllers are working on having Gateway APIs controllers. And this is, and one of the last things that I want to mention about Gateway API is that it's still alpha. So it's a great moment now to add a lot of feedback and give it a try. So I was trying this thing, for example, some months ago, shifting traffic between two namespaces, something that I used to be able to do on the Nginx controller. And this didn't work. Like 100% of the traffic went just to one namespace. So basically what I did is to, in the open, explain my use case, why I was doing this, what did I expect to happen. And apparently I wasn't the only one who needed this. So they actually, on the newest version of the API, they work on some namespace references to make sure that it's something that it can be done, but also it has some safety nets to avoid doing weird things. So that's the website for the Gateway API. Great project. Really looking forward to move to beta. And this is the last way that I was going to talk about doing progressive delivery, not using service meshes. So a little bit of a recap. Service meshes are very good for progressive delivery. They're very good for many things, but they're not required just to do progressive delivery in Kubernetes. The Ingress object doesn't support canaries, as we saw. All the implementations are hacks to the object or intermediate objects, but they all have something. So have a look to those if you're using Ingress. And Gateway API is the new Kubernetes API extension to standardize all these hacks that were happening elsewhere and to also increase to more use cases and more roles, not only L7. And finally, a good observability strategy is key if you want to do progressive delivery, because obviously if you don't have data on how the new version is doing, you don't have right metrics, if you don't have the right strategy, it's very, very difficult to make those decisions. So thanks very much. Datadog is hiring, so if you're interested, please have a look at our careers page. And again, that's my Twitter handler if you have any further questions.
Thank you, Ara. I first had this kind of headachy feeling when you were going through all the problems, and I was like, oh my gosh, this is going to be heavy. And then when you went to the, hey, there's one API to rule the game, I was like, oh my God, I'm so relieved. So I'm looking for some questions from the audience, but maybe while we are checking if there are any, if you would think about this, like you were already getting to that soup of, yes, it's a generic API, but it doesn't support all the use cases yet. But is it possible that it will become like too generic, that you can use it to make coffee, basically? What are the risks?
No. So obviously they have a clear. So it has. If you go to their website and you follow their issues, it's just a gateway API. So anything that it has to be with L4, L7 routing in your cluster is what they try to cover, and that's already a lot, because obviously Ingress, it was a lot easier. It's just L7. It only routes HTTP traffic, something simple. And in this case, what they did is to obviously just one object wouldn't make it, so it has several objects. It has at least 3 of them are very soon moving to beta, which is great news, which are gateway class, gateway, and HTTP route. And gateway and gateway class is kind of similar, are, for example, for L4. So for example, if you are Kubernetes administrator in your company and you want people to be able to deploy gateways, you're able to define gateway classes for them then to define gateway. But obviously, because it's a different object to HTTP route, you're able to give it different RBAC permissions. So for example, only certain groups can create actual load balancers, and then give different permissions to the HTTP route. So I think they also, that's why they also say it's role oriented. It's like every object is going to be used by different people. If you're a developer and you're developing your API and deploying that API to your cluster, probably you care about HTTP route, because that's where you're moving. But probably you don't care about gateway, and you expect someone else to take care of that. So one of the great things about this new API is that they thought not only about what we want to do, but also who wants to do it. And each of those objects are very, very for certain people
it's a really like separation of concerns, basically.
Exactly.
Distributed governance. Really great. So I think that is then the wrap on that. Thank you, Ara, for joining us.
Thank you.